All right. In physics, if you have a position of a particle, so think about this. If you have on the number line, let's say there's a moving particle, okay? And the location of that particle at time t, so here's some particle that's moving. The location of that particle at time t is described as x of t. Let's say that's true. Okay? Since I want a concrete example, I'll even put a function of t, just so that you have some idea of what's going on. 2t squared minus 5t. So suppose you have a function like this which describes the position of the particle at time t. And if you wanted to know the speed or the velocity at time t, what do?
You take the derivative of the...
You take the derivative, because what's the meaning of the derivative again?
It's the tangent line.
Slope of the tangent is first meaning. What's the second meaning? Instantaneous rate of change. That's the second meaning. Okay? So, and if you think about it, what is the velocity? Velocity is really the rate of change of position with respect to time. Isn't that what speed means? What is the speed? To say something is moving with high velocity, what does that mean? That means it's the position is changing very fast with respect to time, right? So Vt is really looking for change of x with respect to change of t. Remember this notation, right? So in this notation, you're looking for how fast the position changes with respect to t, and that means you're differentiating this. So that's 12t to the third minus 4t minus 5, okay? Now, if you have the velocity, then you can again ask the same kind of question for the velocity. How fast is the velocity changing with respect to time? What is that called?
Acceleration.
That's called acceleration, right? So acceleration is the rate of change of the velocity with respect to time. And therefore, you differentiate this, which is 36t squared minus 4. That's the acceleration. Now, if you look at what the physics recommended us to do, eventually this acceleration becomes very important. Why? Because Newton said force is equal to mass times acceleration. So Newton's classical mechanics showed us that acceleration is a very important thing. If you want to predict how things move, it's not the velocity you should pay attention to, it's really the acceleration. Because force is giving acceleration, and acceleration changes the velocity, which changes the position. That's what Newton's rules are. Okay? So the physics recommends us to take two derivatives from the x. Okay? And you can even go further. So there is something called the jerk, which is not really used that much because it doesn't have this fundamental formula like this. But jerk is defined as the acceleration's rate of change. So it's how fast the acceleration is changing. So if there's a sudden change in the force, okay. For example, if you push a brake on a car, right? Then suddenly there's a force that's going against you to stop the car. That sudden appearance. That sudden appearance of force and thus the change in the acceleration is what we call the jerk. And you can go further. So that's why we not only have to know how to differentiate once, we have to differentiate many times. So I'll give you a few examples from now on to compute second derivatives, third derivatives, and so on. So this is the first derivative. That's the second derivative. And this is like the third derivative. Well, let's compute this too. This is 72t. This is the third derivative. and so on, okay?